A spacecraft older than many of its engineers, floating in the void between stars, suddenly starts to falter. Its thrusters, vital for keeping its antenna pointed at Earth, begin to fail. The clock is ticking, and 15 billion miles of space separate the problem from its solution. This isn't the plot of a sci-fi movie, it's the real-life drama of Voyager 1. Join us as we uncover the incredible facts about this cosmic crisis and the ingenious solutions that kept humanity's most distant explorer alive. The clogged arteries of a cosmic explorer. Imagine a spacecraft hurtling through the cosmic void, its lifeline to Earth hanging by a thread. This is Voyager 1, and its thrusters are the beating heart of its communication system. These tiny engines, no larger than a coffee cup, fire in short bursts to keep the spacecraft's antenna pointed precisely at our planet. But after decades in space, Voyager 1's arteries are clogging. The culprit? A microscopic buildup of silicon dioxide, a byproduct of Voyager's aging fuel system. This invisible enemy has been slowly choking the fuel tubes, reducing their diameter to a mere 0.035 millimeters, about half the width of a human hair. With each passing year, the thrusters struggle more to generate the force needed to maintain Voyager's orientation. As Calla Cofield from JPL starkly put it, if the thrusters that keep the antenna pointed at Earth get clogged, that would be end of mission. The consequences of such a failure are dire, potentially silencing humanity's most distant explorer forever. NASA engineers face an unprecedented challenge. How do you fix a spacecraft that's 15 billion miles away using technology older than many of the people working on it? The options are limited, and the stakes couldn't be higher. Yet, in the face of these astronomical odds, the team at NASA isn't giving up. They're crafting an audacious plan to push the limits of remote spacecraft operation, testing the ingenuity of some of the brightest minds on Earth before Voyager's cosmic clock runs out. A cosmic game of musical chairs. Imagine a cosmic game of musical chairs unfolding across the vastness of space, with NASA's Voyager 1 as the star player. This interstellar drama centers around 3 sets of thrusters, each playing a crucial role in keeping our most distant explorer in touch with Earth. At the heart of Voyager 1's communication system are 2 sets of attitude control thrusters, which keep the spacecraft's antenna pointed towards our planet. The third set, known as Trajectory Correction Maneuver (TCM) thrusters, initially adjusted Voyager's path during planetary flybys. Our celestial balancing act began in 2002 when NASA engineers noticed the first set of attitude thrusters faltering. Fuel tubes were clogging, threatening to silence Voyager's voice across the cosmos. In a daring move, they switched to the second set, buying precious time for the mission. As the years passed, history repeated itself. By 2018, the second set of thrusters began to falter, victims of the same microscopic buildup. Faced with the prospect of losing contact, NASA engineers made an unprecedented decision. They fired up the TCM thrusters for the first time since Voyager's 1980 encounter with Saturn. But even this ingenious solution had its limits. Once a beacon of hope, the TCM thrusters eventually succumbed to severe clogging. Their fuel tube openings shrank to a mere 0.035 millimeters, half the width of a human hair. With communication hanging by a thread, NASA made another bold move, switching back to one of the original attitude thruster branches. On August 27, 2024, Voyager 1 reoriented itself using its original attitude control thrusters for the first time in 6 years. It was a nail-biting operation, pushing the aging spacecraft to its limits. As we celebrate this triumph, we're left to wonder about the future of our intrepid explorer. How many more moves can Voyager make in this high-stakes cosmic game before it falls silent, drifting eternally through the vastness of interstellar space? The cold equation, balancing power and heat. Imagine piloting a spacecraft with batteries that have been slowly dying for over 4 decades, 15 billion miles from Earth. This is NASA's current challenge with Voyager 1. As Voyager 1 journeys through deep space, its power supply is fading. The spacecraft's nuclear batteries lose about 4 watts of power each year. In the vastness of space, every watt is crucial. NASA engineers have been making tough decisions, gradually shutting down non-essential systems to preserve energy. This power-saving strategy has an unexpected side effect. Voyager 1 is getting dangerously cold. As heaters and instruments go offline, the temperature inside the spacecraft drops dramatically. NASA now faces a daunting task: how to warm up thrusters that have been inactive and freezing for years without causing irreparable damage. The stakes are high. Activating thrusters that are too cold could permanently damage them, potentially ending Voyager's mission. Yet, leaving them inactive isn't an option either. Without functioning thrusters, the spacecraft can't keep its antenna pointed at Earth, cutting off our connection to this intrepid explorer. In a stroke of brilliance, NASA engineers devised an innovative solution. They decided to redirect power from one of Voyager's main heaters to warm the thrusters. It's a delicate operation. Insufficient heat could lead to thruster failure, while too much could harm vital scientific instruments. As we await the results of this daring maneuver, it's clear that even at the edge of our solar system, human ingenuity continues to expand the limits of space exploration, a 15 billion-mile remote control operation. Imagine the nerve-wracking task facing NASA's team as they prepared to repair a spacecraft so distant, light takes 22.5 hours to reach it. This was the world of interstellar troubleshooting, where patience becomes an absolute necessity. At NASA's Jet Propulsion Laboratory, engineers gathered around their consoles, ready to execute a carefully choreographed sequence of commands. Each instruction had to be perfect. There was no room for error when dealing with a 47-year-old spacecraft billions of miles from Earth. The team began by turning off one of Voyager 1's main heaters to free up precious power. Then, they activated the thruster heaters, warming up systems that had been dormant for years. As each command disappeared into the void of space, tension grew. Unlike Earthbound repairs, there was no immediate feedback. The engineers had set in motion a cosmic dance, and now they could only wait for their distant partner to respond. For 45 hours, the time it takes for a signal to reach Voyager 1 and return, the team could do nothing but hope. Had they just saved Voyager 1 or accidentally silenced it forever? Finally, after nearly 2 days of anxious anticipation, the signal came through. On August 27, 2024, Voyager 1 confirmed the impossible. Its attitude control thrusters were back in action. For the first time in 6 years, the spacecraft successfully pointed its antenna back at Earth, re-establishing the vital link to its home planet. Against all odds, NASA's daring maneuver had worked, breathing new life into humanity's most distant explorer. Lessons from a 47-year-old space pioneer. Voyager 1's reawakening has brought us more than just data. It's delivered invaluable lessons from its nearly half-century journey through space. This cosmic veteran has unlocked secrets that could shape our future among the stars. The spacecraft's endurance in harsh space conditions has become a blueprint for modern mission designs. Its robust components and adaptable systems have redefined our understanding of durability in the cosmos. Every creative solution, from thruster swaps to repurposing old tech, has advanced our space engineering knowledge. As Voyager 1 continues its voyage through interstellar space, it beams back crucial data about our heliosphere and its role in shielding us from cosmic radiation. This information transforms our understanding of our solar system's place in the galaxy and guides future deep space missions. The recent thruster troubles and their solutions highlight the ingenuity behind this extraordinary machine. NASA engineers, many born after Voyager's launch, have had to innovate to keep our most distant explorer communicating. Their problem-solving skills, like using power from a main heater to warm cold thrusters, exemplify the creativity driving space exploration. Maintaining contact with Voyager 1 is a remarkable technical achievement that continues to expand our knowledge of the cosmos. As we listen for its faint signal from the edge of known space, we're reminded of the vast journey that lies ahead in our quest to understand the universe. The final frontier, Voyager's uncertain future. Voyager 1's signal weakens with each passing year, a testament to its incredible journey into the cosmic unknown. As our intrepid explorer pushes deeper into interstellar space, it faces challenges that test the limits of human ingenuity. Current estimates suggest Voyager 1 will continue transmitting valuable scientific data through at least 2025, with engineering updates potentially lasting until 2036. However, its nuclear power source weakens by about 4 watts annually, forcing engineers to make increasingly difficult choices about which systems to keep alive. The next hurdle involves switching to a set of attitude propulsion thrusters that have been dormant for years, a risky move that could mark the end of our ability to communicate with the spacecraft. Yet, even when Voyager 1's voice falls silent, its journey will continue. NASA has prepared for the day when our distant emissary travels beyond the reach of the deep space network, reflecting our hope that we might someday reconnect with our cosmic messenger. Voyager 1's legacy as a triumph of human exploration is already secure. It demonstrates the incredible durability of technology designed nearly half a century ago and continues to feed our scientific curiosity. As it sails through the vastness of interstellar space, Voyager 1 inspires future generations of explorers and reminds us of our place within the cosmos. Long after its signal fades, this tiny ambassador of humanity will carry on its silent journey, bearing with it our hopes, dreams, and an enduring message to the stars. Voyager 1's ongoing mission serves as a bridge between our present understanding and the infinite possibilities that lie in the unexplored reaches of space. Voyager 1's recent thruster swap showcases the remarkable longevity of 1970s technology and the problem-solving skills of NASA engineers. From a staggering 15 billion miles away, they breathed new life into a spacecraft older than many of them. As Voyager 1 continues its journey through interstellar space, it unveils new secrets about the heliosphere and the vast realm beyond our solar system's edge. Each data packet beamed back to Earth adds to our understanding of this cosmic frontier. The Voyager mission stands as a testament to human curiosity and perseverance. Its ongoing voyage reminds us that groundbreaking discoveries often emerge when we push beyond perceived limits. As we look to the future of deep space exploration, Voyager 1's legacy inspires us to keep reaching for the stars, driven by our insatiable desire to uncover the mysteries of the cosmos. If you're as fascinated by this story as we are, then you won't want to miss our next video. In it, we'll dive into another fix that was made to the Voyager 1's flight data system. Click that video now, and let's continue our journey together. Thank you for joining us on this cosmic adventure. Stay curious and keep looking up.